All right. So previously we have studied about how to make like a different numbers. Okay, not like different numbers. How many ways can we make numbers? One is by using a digit only once, and one is by digit using a digit multiple times. Okay.
Mm.
All right. Now let's get to something advanced. Something a little advanced. Maybe it might take the whole 1 hour to do just one math. That is, how can we get the like total or summation of all the numbers that we have created? How can we get the summation of all the numbers that we have created? Okay, so let's try that. Okay, so see, summation of created numbers. It is numbers. Say we have two digits there, those are 1 and 2. By using them, we can make only two numbers, that is 12 and 21, right? Okay,
Yes.
all right. So now, what will be the obviously by using only once, okay, by using the digits only once, because if we would be able to use them multiple times, then we would get two more numbers which are 11 and 22. Okay. So the summation of these are summation would be 33, right?
Yes.
12 plus 21 equals to 30. Now, whenever we are working with say like a huge number of digits and we create say for instance 1000 numbers or maybe 1500 numbers, we cannot be like making all the digits and then using the calculator to calculate the summation. Okay, so we have to find a formula. So what is the formula? That is what we will see. Okay, so first of all, let's say again, let's see, 1 2 3 4, 4 digits, and the numbers that could be created are 2 3 4 1, 2 4 3 1, 3 4 2 1, 3 2 4 1. Just a second. 3 2 4 1, then 4 2 3 1, then 4 3 2 1, and like this there would be various. Okay, I'm not writing all of them. Okay, and eventually what the total you will get is 66,660. 660. Okay, all right. Now again, whenever we are working with like say 1 3 and 2, three digits, 1 3 and 2, three digits, we will get a total of say 1332. Okay, now the point is, how are we getting this? Okay, how are we getting this? This is just like whenever we are say calculating all the numbers that can be created and then adding them up. So there is a particular formula to that. That is, whenever you are trying to like get uh, the summation of all this, what you have to do is all the digits. You have to sum all the digits. Okay, so summation all digits times n minus 1 factorial. N minus 1 refers here to how many how many digits number are we trying to make? Say for instance, if we want to make a 3-digit number, then n equals to 3. If we want to make 5-digit number, that would be n equal to 5. Okay, so n represents how many digited number we are trying to make. Okay, and lastly multiply it with 1 1 1 1 in ones, actually in ones. Okay, if I write it like that way, say if I want to make, say for instance, a four summation of 4-digit numbers, then we will use 4 ones. Okay, if I want to create like summation of 3-digit numbers, we will use 3 ones. Okay, and notice, let's see if this satisfies this 66,660 or not. Okay, so what will be the summation of all digits? Summation of all digits will be, tell me.
10.
10. That is 4 plus 3 plus 2 plus 1. Now we are creating 4-digit numbers, that will be 4 minus 1 factorial times there would be 4 ones. Okay, can you see by calculating it if it's correct or not?
Mm, okay. 1, 2, 3, 4, 5, 6, 7. 407,955,200.
What?
I do not know.
Okay, okay, just let me check 1 second. Okay, I don't know what you have done. See, maybe you have done some mistake. See, this is 10, all right? So 10.
Yes.
And what is 3 factorial? 3 factorial equals to 6, right? And then 1 1 1 1. This would equal to 66,660. Okay, this will be the answer.
Where did you
Yes.
get 6?
3 factorial equals to 6. 3 factorial equals to 3 times
That
2
is
times
not.
1 equals
That's
to
not 9. That's 4. Oh, okay. I thought that was 9.
Oh my gosh.
That's why.
Where will I get 9? There is no,
That's
I'm
why I was confused.
okay. All right. Okay. So understand this thing. I haven't read how this formula was created by mathematicians. Maybe that was like pretty high level. I don't know if it's in your book. If it's in your book, please let me know. Then obviously I will teach you. All right. All right.
Yeah.
All right. Now, um, okay. Now, let's do another one. That is, say you are given with 4 digits, which are 3 4 6 and 7. 3 4 6 7, 4 digits. Okay, 4 digits. Now you are allowed to use them only once. Use them once, only once, to make numbers. What is the summation of all the numbers created. Tell me, you will do this one, okay? Very easy. Just plug in the values in the formulas.
133,700. 133,320.
Very good. Okay, all right. Excellent. So now we are done with the easy part. That is, whenever we were given, say, uh, 4 digits, and we had to make like 4 digit numbers, or maybe 3 digits and 3 digit numbers. Okay. Now, to make things a little difficult, let's do something like not actually that much difficult. Okay, I'm getting to that. Okay. So whenever um, mm, calculating summation, you could say it's like what can I say, a proof or something, summation of created numbers. So its step one would be, what was the step one? It was calculating sum of the digits. That would be equal to summation of each digit times repetition of that digit. Repetition of that digit. Okay. Now the point is, how can we calculate the repetition? Okay. So how to calculate the repetition? Okay. So whichever digits repetition is to be calculated, fix it on a spot. Okay, on a spot. Then what will you do? Then find how many ways you can fill up you can fill up remaining blank spots with remaining digits All right, so say for instance you are given, say, 5 digits, okay, which are 1, 2, 3, 4, and 5. Now you want to calculate how many what will be the summation of the three digit numbers created by all these. Okay, so now how can we calculate the summation? Okay, so first step was to calculate each digit times sum repetition of the digit, to calculate the sum of the digits, right? So let's see. So let us first of all fix, say for instance, fix 1 here. So we are left with 4 digits. How can we fill up the 4 digits in this spot? In how many ways? Tell me.
Sorry.
There are 4 digits left. If I have fixed 1 up here, as we said that whichever digits repetition is to be calculated, fix it on a spot. So I want to calculate the repetition of 1, right? So I have fixed 1 first of all.
Okay.
Then I have to calculate the remaining digits, because whenever we are trying to calculate the repetition, that means that how many ways can it be repeated, right? I mean, fixing it in a spot, if I take say 541, then say 231, that means 1 is getting repeated, right? 1 is here at this spot, then again in this spot, so it is being repeated. Understanding my point?
Yes.
Okay, so now what I was saying, first of all, answer my question, that is 1 is fixed here, so how many digits are left if 1 is used?
2.
Not 2, 4. Okay, 2, 3, 4, 5.
Uh,
Right? So how many ways can you fill up these two spots?
4p2.
4p2. Excellent. So 4p2, right? 4p2. Now obviously, what you would understand is how total number of like 3-digit numbers, how many uh, total of 3-digit numbers can you create using 1, 2, 3, 4, and 5?
In 2 spaces.
Sorry? No, in
I
3 spaces, in 3 spaces.
in 3 spaces.
Yes, 3-digit numbers.
4p3.
5p3, right? 5p3, there are
5p3. Sorry.
5p3. Okay, that is equals to 60. All right. And now if it would have been said
Wait,
that, yes, go ahead.
I'm confused. Like, uh, why is there an X on next to 1 in the boxes?
No, I mean, it was for your understanding. Okay, so see, it was like I have, I mean, occupied this spot. How have I occupied? I have occupied this spot by using 1. That is what I wanted to do. This is only 1 box. This is not 2 boxes, right? All
Oh,
right.
that's all. Oh, that's 1 box.
And what does this repetition mean? See, the 1 will keep on getting repeated at the last box, okay, and we will keep on orienting the numbers in the the first 2 spots, okay. That is why we are calling it a repetition. That is why we are calling it a repetition. All right. Okay, so anyway, so and in case if we were allowed to use it like multiple times, then the things would be again the same. We will fix a particular digit in one spot, and we will still have then 5 digits left, okay. Then how many ways can we fill up these 2 boxes with 5 digits?
5p2.
I have again said like you can use multiple times.
Uh,
You can use a digit multiple times, not only once.
oh, so 5 to the power 2.
Yes, 5 squared, right?
Yeah.
Okay, now why have you chose the value of n to be 5?
Because n is the things that can be that multiple things can go into something, and the R is the other one, the one that cannot have multiple
Okay, if you
in
have
it.
confusion regarding this, I mean, yes, I told you 2 things. One is that whenever you are trying to figure out which should be the value for n, you have to see if that particular object, if that particular value can take multiple I mean values at one time, right? Multiple values at one time. See, if there are two objects, right? Here the two objects are, one is digit and another is box, right? These are the two objects which we are dealing with. Okay, object or thing, what
Right.
whichever way you want to call. Okay, and the digits value is here 5 and box's value is 2. So n has to be either 5 or either 2. Now let's see, can a digit take multiple boxes at a time? The answer is yes. You can make a number like 1, 1 and 1. So a digit is taking 3 boxes at a time. But can a box take multiple digits at a time? Say I write down 11 in one box? Tell me.
No.
The answer is no. So this is how you have to figure out what should be the value for n. So the value for n would be the number of digits. And also I told you, whenever that was just like a hack, you could say, that is, if you don't remember this thing, just for like making numbers, whenever you are making numbers, the number of digit will be the value of n. Okay, so you have to be very careful about that. Okay, because I myself used to get confused with this thing. All right,
Mm.
anyway. Okay, so now I hope you understand the thing, like what repetition means. Repetition means whenever you are fixing these things, say for instance, um, it's like, say for instance, we are making various numbers like 541, 231, 321, maybe 341, but the one's position is being repeated at this particular spot. That is how we are calculating the repetition. That is how we are calculating the repetition. Understand my point? Tell me.
Yes.
Okay. Now you might ask, so what is wrong in calculating the previous way? That was like n minus 1 factorial. So the thing is, n minus 1 factorial won't be the repetition of that digit in this time. Okay. If you tell me that 5 minus 1 whole factorial, it won't be the repetition of a particular digit. Okay, can I erase something? Let me show it to you.
Yes.
So if we are calculating the repetition in that way, that will be wrong. So for instance, previously we were calculating a 4-digit number and we were given 4 digits, right? We are given 4 digits. Okay. So 1, 2, 3, 4, 4 digits and 4-digit numbers. Okay. Now say we have fixed 4 up here. So there are 3 digits left, right?
Yes.
So how many ways can you fill 3 boxes using 3 digits?
Yeah. Three. Power of three.
You can use only once, not two,
Oh, then 3p3.
right? 3p3. Now 3p3 is exactly equal to 3 factorial. 3p3 is exactly equal to 3 factorial. Understand my point? So that is why
Yes.
I previously said to you it will be n minus 1 factorial. But notice the two examples that I gave you, all of them were 4 digits were given and 4-digit numbers were given. So that is why it was becoming like 3 factorial. Okay, but considering 3p3 or maybe 4p2, that is more appropriate. Okay, so that is why I said each digit into repetition of that digit and times in times of 1. Okay, understand my point?
Yes.
Okay, so previously what we got, the each digit, so each digit was a summation of each digit, so summation of, so each digit could be like it could be 1 times 4p2 because that was the repetition of the digit. Okay, all right. Now summation of
Yeah.
each digit. Okay, so whenever we are dealing with summations, as you know, Say for instance, if it's like summation of x square and x is equals to 1 up to 5. So what do we write? We write it like 1 square plus 2 square plus 3 square plus 4 square plus 5 square. You know that, right? Do you know this operation of
Mm,
summation? Okay. So this means that x equals to 1 up to 5. That means x's value will start from 1 and end at 5. So 1 square plus 2 square plus 3 square plus 4 square plus 5 square. Okay, and we call it 1 up to 5, starting from 1 up to 5. That is why 5 is at the top and 1 is at the bottom. Okay, now here it's not typically like that, but we have to calculate the summation using each digit. Okay, so say we are nullifying this summation sign. Okay, so we are using addition sign. Okay, so tell me what will be the next digit and repetition of the digit. Tell me.
6 squared.
We had 5 digits, right? 1 2 3
Yes.
4 and 5. So we have calculated the repetition of 1. So how can we calculate the repetition of 2? Let me show it to you again. Let us fix 2 up here, right? Let us
Mm,
fix 2 up here. So how many ways can you fill up these 2 spots?
4p2.
4p2, right? So according to our formula, we will apply that each digit, that is 2 in this case, times 4p2. Again plus 3 times 4p2. Are you understanding now, or do I have to show the 3 one as well? Okay, let me show it to you, just a second. So fixing 3 up here, then 4 digits, then 4p2. Understand my point?
A bit.
A bit. Okay, see. Okay.
Sorry.
All right, so see, if we try to figure out, say 3 is fixed here. Okay, so there would be 4 4 digits to fill up these 2 spots. So we can get 1 2 3, we might get say 2 1 3, we might get 4 5 3, we might get 5 4 3. Okay, so each of the time 3 is being repeated at one spot. Okay, and other numbers are orienting or arranging between them. So that is why we are calling it a repetition. Are you understanding why are we calling it a repetition?
A bit, yeah. No.
So
Good.
what is repetition? Repetition means we repeatedly study at 12 p.m. on Sunday. That means each and every Sunday many things will change, but we will study at that time. So here you can also see the digit 3. He is repeatedly coming in the last spot, but the other things around it are changing. That is what repetition is. Okay, in like general sense. Okay, you repeatedly go to school from Monday to Friday. Everything will change, many things will change, but you will repeatedly go to Monday to Friday at school. Try relating it with the real life things. Understand my point? Okay,
Yes.
so that is how we are getting the repetition. So again for 4 it will be 4 times 4p2 plus then again 5 times 4p2. Now if we try to relate it back to the previous formula which was given to us, let me erase some portions as well. So that would be, see previously what was the formula, can you tell me? It was
The one to sum up everything.
yes, sum of that was sum
Sum
of,
of all digits
yes,
times
times,
n minus 1 factorial
right. Okay, so
times
now,
the number of.
right, okay, so now if I take 4p2 in common or factorize 4p2, what will I get?
Um,
Tell me.
Factorize. What?
If I factorize 4p2 from all the 5 additions, what will I get? I will get 1 plus 4
4p2.
plus 4 plus 5, right? Is that correct?
Yes.
Is it correct? Did you understand? I've just factorized it. You have read factorizing previously, right?
Yes.
Okay, so I have taken 4p2 in common. You can also say I have taken 4p2 in common. That is why There were addition signs, and I have done like 1 plus 2 plus 3 plus 4 plus 5. So if I relate it